today we are going to start this kind of little experiment. I mean, this is the first time for me to teach in a Korean university. I am sorry I cannot speak Korean. I hope that you do speak some English enough to understand the seminar, to follow the seminar. The content, I mean, I would like first to introduce a little bit what we are going to be doing for the next 2 weeks. So there is a kind of little intro, and then we will go into the first of the 9 sessions with content. The 10th session, because we are going to have 10 sessions in the next couple of weeks. The last session will be a collective discussion between all of us. And I know, I mean, I don't, because I've never taught in a Korean university, but I taught in other universities in Asia. I know that Asians are slightly more shy than Americans. So I would like you for this last session to overcome your shyness and come with questions. So I'm going to be talking to you for 9 sessions, and now I will explain what I'm going to be talking about. And what I would like you to do is to catch some idea among these 9 sessions for the last day, and maybe come with a question or a proposal or something that interested you from the content or from the seminar content. So that's basically the structure of the seminar. As you know, because you've seen the poster, the seminar is called the Posthuman City, and it is very much based, and this was also one of the interests in doing this here in Seoul, because it's very much research that comes out of the Seoul Biennale that I had the fortune to kind of direct in 2017, which was called Imminent Commons, and that maybe as a kind of reference guide you can look in these 2 catalog books that were published at the time of the Biennale, and so the Biennale was called Imminent Commons, right? Although my preferred title was the Posthuman City, but for a number of reasons, I think Imminent Commons was also a good title, but the idea of the seminar is very simple, and it is proposed in a kind of polemical form, which is that both ancient and, well, not ancient actually, but maybe 19th century and 20th century urbanism was primarily driven by humanist principles that put humans at the center of the discipline and the practices of urbanism, and and even the postmodern revisions are also based on humans as their main concern, and that means that either functions in the modernist tradition or identities and communities in the kind of maybe social constructivist traditions are focusing the practices of making cities around the idea of the human. And in some ways, the proposal that I would like to make here is that since the modernist times, there are a number of things that have happened which suggest that the exclusivity of the humans as the core of cities is no longer viable, and I would like to say there are 2 main reasons for that. One is the ecological concerns that we have now about how cities operate. I mean, cities absorb over 60% of the energy is absorbed in city, and over 50% of the carbon emissions are produced in cities, and so that is transforming climate, the world, the earth, and so that is something that transcends human concerns. It's basically cities are transforming nature, and therefore we can no longer make humans the only concern of urban practices. The other one is probably the rise of automation, robots, etc., which also give rise to concerns that are not entirely human. I mean, artificial intelligence will be the kind of most current concern, but the fact is that now there is a different type of intelligence that is not human, that is going to and is already affecting cities, and that means that we need to think about agents that are not only human. When we design cities, or when we think today about cities, there is a certain resistance to this. There are people, and I think there are interesting resistance to this, which is that there are people who are demonstrating within cities and asking for again human concerns, both the kind of racial disturbs, or one issue that I thought was very interesting that happened also in 2020. These two events, the George Floyd demonstrations and the Gilets jaunes, the demonstrations in Paris, and their complaint about the fuel taxes, which were aimed to mitigate environmental damages, show that perhaps human concerns and non-human concerns, which are the ones that we are going to be dealing with, are sometimes opposed, are sometimes politically at a conflict that I think is interesting to think. I mean, particularly in the case of the Gilets jaunes, which is an interesting case for me. We have demonstrators that are complaining about fuel taxes. They are complaining about political policies that are aimed to preserve climate. And so for me this was a very interesting moment, because it was at the time when I was constructing the seminar. I think what is interesting about that is that they are complaining about class struggles and social struggles, and these social struggles are pitched against a concern that is ecological. And so that conflict, I think, is very much part of the conflicts that we have to solve. I'm not sure that I know how to solve them, but I believe that part of the thinking in the seminar will have to address these concerns. And again, there are a number of other political concerns that are related not only to ecology, but also to intelligence, and some of them we could see them in both during the construction of Brexit and during the election of Trump, in which a number of agents, which I would call the first posthuman politicians, are manipulating data in order to change the outcome of democratic processes. So machines, these people like Bannon or Cummings or Mercer, I mean, we could maybe talk about them, but what I think is interesting about these people is that they are people who understood that machines vote somehow. So there are people who are capable of manipulating machines to change the outcome of political elections. And so on one side we have humans versus machines, human versus ecologies, and in a way what the seminar is going to try to do is to see or to analyze the history and the casuistic in contemporary cities that have to do with a non-human perspective on cities, with the way in which non-human actors or agents affect cities. And so there is a number of, I would say, almost populist bibliography, which describe a series of emerging social, economic, and political phenomena which place these human functions on a secondary place due to the changes in regimes in economic integration produced by new technologies, Jeremy Rifkin, Paul Mason, the end of work, Jeremy Rifkin again, the rise of the robots, the economics of climate change, which changes everything, from Naomi Klein. And what I would also like to mention is that the seminar has 9 sessions. The 4 first sessions have to do with urban ecology and are based in a way on the work, not the work, but basically the position of Louis Mumford, who is also a disciple of Patrick Geddes on one side, but so the city as part of a natural ecology, that will be basically Mumford's position, and these 4 commons, let's call them like this, are based on the arcane elements. So air, water, fire, and earth. I think in Korean arcane traditions there are 5 elements, but I'm not, I think I've discussed this in the past with some Korean colleagues, but in the Greek mythology, in the kind of, let's say, European mythology, there are 4 elements that constitute the world, and these are the 4. And in some ways what I am proposing is that these 4 arcane elements remain the center of urban practices. So when we design cities today, we are working with air, with water, with fire, which is energy, is the same as energy, and earth. Earth would stand for, let's say, vegetation, nature, biology, biomass in cities. So these are the 4 concerns that I think the contemporary city should look at outside the human social constructivist concerns. We need to almost go back to the arcanes of the city. And the other 5 elements are based on technologies, and they are somehow based on McLuhan's understanding the extensions of man, in which McLuhan theorizes about human functions like sensing or communicating or moving. So these are things that we do as bodies. We sense, we communicate, we move, we walk, we consume, we digest, and we throw away, we create, refuse. And so these 5 functions, very much along the lines of what McLuhan talks about medium or media. So these 5 concerns have become in some ways autonomous and transferred to machines. So that we use cars to move, or planes, or other devices. We use sensors to sense things that we cannot even sense with natural senses. We use mechanisms like mobile phones to communicate with each other, and so on and so forth. So there has been some sort of status that these mechanisms have created that have made them to some degree independent. So these are the 5 commons of technologies. So 4 commons of ecology, 5 commons of technology. These are the 9 sessions that we are going to look at. So this is sorry, I should have had, I'm like, this is what I should have shown you before with what I was talking, and so these are the sessions that we're going to see. And as I said, the last day I would like to host some sort of collective discussion with all of you. So the sessions are as urban air, which is the one we will do today, urban water tomorrow, urban energy on Wednesday, urban biomass on Thursday, and then on Friday we will move to the technology commons, urban sensing, urban communications, urban mobility, urban production, and urban recycling. So these are the 5 technology commons that we will see. So that's basically the structure of the seminar. You will see now we are going to move to the other PowerPoint, which is the urban air one, and you will see that I will show you a lot of material. The seminar is designed for 1 term. So that's basically one of the kind of problems that we have here, is that every one of these sessions is designed for 1 term, in which every week I do one of these sessions, or every 2 weeks I do one of these sessions, and then you have time to read. I think Eric has told me that he's given you some bibliography that you could read before. The ideal situation is that I will give you the session, then you will have time to read the stuff, and we will have a discussion about this the following session, and so on and so forth. But because of this situation, we need to compress it. But I think it's an interesting experiment. I believe it can work. You are not going to be able to digest all this material in 2 weeks, obviously. But in some ways, it doesn't matter, because the sessions should give you maybe a cue of things that you can look at in the future about every one of these issues. And then ideally for the last Friday, you can maybe from one of these issues select, maybe somebody's interested in mobility, or somebody's interested in water, or somebody's interested in whatever. Maybe look at the session and come up with 1 question for the last session. Usually you will need to write a paper and participate into discussions on a weekly basis, etc., etc. But we cannot do that, so we are going to do it like this. You will see that the sessions, I'm not going to teach you much design. I'm gonna give you a kind of history, like a short history of every one of these commons. So in every session we will look mostly at 19th and 20th century history of how water in cities has occurred, or how air, what is the history of air regulations, air technologies, air sensing, the transfer of, or the kind of embedding of air concerns into architecture or urbanism. That's what we will see today. And so that's, I mean, for those of you who may be interested in following the 10 sessions, I think that is what you should think in getting out of this seminar. So let's move on to the first session, urban air. If you don't understand something, or if you have some urgent question, please feel free to interrupt. I don't mind. I like, you know, if somebody wants to, I mean, also for Eric and Joan, who maybe are less shy. If you want me to kind of focus on something, or you see something in what I say that maybe will be worth considering the light of something that is happening here in the school or whatever, please feel free to interrupt me. I don't know whether we will have time to maybe do a short discussion about this session at the end, but basically let's start. So urban air is, I mean, air is actually, for me, is maybe the most difficult common, because it's something that is very difficult to perceive. I think the problem of air, which we know now, is is a very important concern, because there are maybe 7 million people who die every year out of pollution problems. Now, I mean, every year they say there is more and more people. So breathing is obviously a human necessity, and we have only recently become aware that this is a global problem. These are pictures of different cities in the world where, you know, there are important air pollution problems, and particularly here in Korea, you know that you know, the yellow dust and so on and so forth. So you are well aware that there is an issue with air, but the question is, how does air affect the design of cities, or what is the history of thinking about air when thinking about cities? That's basically what we are going to discuss today. Today also we know, let's move to the next one. Forget about that. But I mean, this kind of visualizations is something that we didn't have 10 years ago. So it's only now where we have tools for the first time that enable us to see, basically how air moves. I mean, and we will see this through the presentation, but it's a very recent development that we have the capacity to actually model the air and see how the air moves in this room and where the particles are. I mean, when I prepared this seminar for the first time in 2017, when we were doing the Biennale, obviously COVID had not happened. So we were looking at epidemics, at SARS and other epidemics, as some of the impact that air movement has on populations. But now, obviously, after COVID, we know that the movement of air is something that can affect radically urban populations. And so COVID was a very exciting moment. Because in some ways confirm some of the things that we had been discussing in the Biennale, which is how important the limits or the borders of space may be for people living in cities.
What you're looking at.
We don't need the sound. But anyway, so this kind of evidence is something that people, maybe people in NASA had it 20 years ago. General citizens didn't see something like this until very recently. And we know now that this is the proof that the air issue is a global problem. It's not happening in Seoul or in London, it's happening everywhere at the same time, and it is interconnected. That's, I think, one of the things that is interesting about trying to think about how air will modify the structure of cities in the future. So I already mentioned that one of the interesting questions about COVID was the fact that was an air transmitted disease, and there was a number of physical devices that took place during the COVID time that had to do maybe with how to redesign cities based on air movement. So there is pollution, and there is epidemics that have to do with air and obviously climate. And so these are things that we we are now aware of. And this has raised to a whole new phenomenology that has to do with how people dress in the city, or how people play sports. This is Beijing. This is the air in Beijing is so bad that basically you cannot leave kids to play in the outside because they are basically breathing toxic stuff. And Beijing is maybe an extreme case, and this also has generated a whole new set of protocols, urban protocols, that have to do with communicating the air quality through phones, mobile phones. Now we all carry one of these things with us, and these things can actually measure the pollution and communicate with other people and say how is the air in the place where we are located. So this is a very interesting possibility of some sort of collective brain communicating the air quality. There is also these mechanisms that we can use to model air and to sense air. And this has been taken over by a number of thinkers and artists like Chai Jing, the famous documentary about Under the Dome, which had to do with urban pollution in China, or Naomi Klein, This Changes Everything, Capitalism versus the Climate. But all these issues go back to some things that are very very arcane, very ancient knowledge, and this is why, in some ways, I'm saying that these concerns about the posthuman are not entirely contemporary, are also arcane. They existed in all cultures. Feng Shui, which is, you probably know better than me, or Vastu, or all this kind of arcane knowledge about how to design cities, was already considering air. And air was not human. Air was air. It existed outside the human actions, the human interactions. And so I think that it's interesting to think about what we are going to be seeing, not only with air but with water and so on and so forth, as some sort of reminiscent or resonant with arcane concerns about life, urban life or rural life. In the West, much later than Feng Shui and Vastu, there is Vitruvius, who talked for the first time in a treatise about air as a concern of cities, as a concern of urbanism, and Alberti also reading after Vitruvius. And it's interesting because even if Alberti and Vitruvius date back from the European Renaissance, air was always some sort of people knew in the 19th century, in the 18th century, that air could be toxic, that air could be dangerous, and there were all kinds of almost magic thinking concerns or interpretations about how air can be toxic, and they used to call it miasma theory or bad omen. It was almost like some sort of how do you say, when somebody basically condemns you and kind of makes some sort of spell, makes a bad spell on you. That's how people understood in the 19th century air, as something that can be bad for people, but it was a kind of intuitive knowledge. It was not a kind of scientific constructed knowledge, and it was in the beginning of the 19th at the end of the 19th century with the kind of industrialization in Europe, and in England was probably the most industrialized culture or civilization at the time, when people started to realize that the smoke that was produced in the factories was poisoning or was dangerous or was toxic to some degree, that people started thinking systematically and scientifically about air. They didn't have the tools that we have today, but they knew because of this pollution that that air could become dangerous for people. And so in 1863 there is the first environmental protection regulation related to air, which is the Britain's Alkali Acts, which was attempted to limit the discharge of industrial byproducts, mostly hydrochloric acid, in the production of soda ash, which people realized that it was that it could have very negative effects to the health of animal and plant life. So it was not even about people. People were realizing that these factories were poisoning the surroundings of the cities, the nature, the farms surrounding the cities, and that created the first Alkali Act, which is the first regulation in the world limiting or regulating the toxic emissions of factories. And there's immediately after, there is a very interesting debate in which some very well-known British physicist, John Aitken, which was concerned with these issues, drew attention to the antiseptic powers of smoke and sulfur. And so this is also something that is interesting when thinking about air, which is very easy to deny. One of the problems that we have to plan or to make policies about air is that it's very difficult to grasp, because there is very difficult physical evidence of it. I mean, now there is real evidence because we have certain tools, but imagine that in the 19th century they didn't have these tools. So there were people who were saying, well, yes, it may be toxic, but it's also, I mean, this guy, John Aitken, was almost a denier of the toxicity of air, and was saying that yes, the smoke and sulfur emissions may be bad sometimes, but they were also helping to kill the germs that created urban epidemics at the time. So all these things, and then there are the Coal Smoke Abatement Society in 1898, which is a group of activists in London who wish to put pressure on London City Council to introduce legislation to reduce pollution, because they had realized that pollution was actually killing people in the city. So there is these are the first time that there are legislation and people concerned about air in cities. And at the same time, there is the other side of air problems, which is air transmitted diseases. Probably the most famous case before COVID, and it's also very interesting because we were looking at these examples before COVID, but we had never experienced a pandemic. I had never seen a pandemic before. My parents' generation, for example, lived 80 something years, and they never experienced a pandemic. So their pandemics, as you know, so far historically have happened every 100 years. The last one was what was called the Spanish flu in 1918, which took a greater toll on human life than the collective casualties of World War I. I mean, these were kind of very serious events that actually killed enormous amounts of people that had nothing to do with, in a way, human concerns, that were viruses or bacteria that were infecting people, like COVID, and you couldn't do anything. That had nothing to do with class struggle, gender struggles, or race struggles, nothing, community struggles, nothing to do with that. They were humans and germs or viruses. And so those type of relationships are some of the relationships that are mediated by urban air. Another interesting moment in terms of making people aware of the importance of air is basically war, and there are moments like the one that is shown in the slide, where the concern about chemical warfare became so acute in Europe. Again, England was one of the pioneers of these concerns, where people were literally starting to wear masks in the street for fear to breathing air. According to Peter Sloterdijk, who is, I think, one of the references that you should all look at. I mean, the book of fear of, how is it called? Terror from the Air, if anybody is interested, from Peter Sloterdijk, is a very interesting book where Sloterdijk, who is, I think, one of my favorite philosophers, says that the 20th century starts in 1915, when the German army released its first chlorine gas attack in Ypres, in France, northern France, because it was the first time, this is Sloterdijk's theory, is the first time where people realize that air can be weaponized, that you can entirely design an environment for people. It's not just about water or air. I mean, basically, everything can be designed by humans. And so for Sloterdijk, that moment of the first chlorine gas attack is the moment in which the 20th century starts. I mean, this is his theory. Maybe he's exaggerating, but I think it's a fairly interesting interpretation of the importance of air. And so it is very interesting to see that people were not aware of this, and the authorities in England were making this type of advertising to warn people that they can be killed by air. So that is, I think, a crucial moment in which the people in the city, the normal people, become aware of air as something that is tangible, that can actually kill you. So there are these kinds of amazing graphics that the government made to warn people that they can be killed by air, by toxic air, by chemical warfare. And kids were trained to put masks in schools, etc., etc. In the US, also the concerns about air. I mean, they first started in England, and they moved to the US, where the Sierra Club, which is still existing, started mobilizing to push legislation that limited air pollution. And in 1926 there is a Public Health Act, and then basically it follows by the 1956 Act, Clean Air Act in the UK, which happened after the 1952 Great Smog in London. In London there is a famous moment in 1952 where there is a concentration. For some reason there is a concentration of pollution over London, and that killed quite a lot of people. And 4 years later, the first air polluting act takes place in the UK. I'm giving you a kind of little history about how people became aware of the importance of air. Now we're going to move to a slightly different side of this issue, which is how the air becomes interiorized into the architectural practice. So probably some of the first concern about air have to do with urbanists in the 20th century. These are drawings from 1910. The Cities of the Future, which is a book written by Eugène Hénard, a kind of French urbanist that started to conceive cities as complete systems that process air, water, refuse, transport, etc., etc. One of the things that Hénard says is that garbage and rotten water and things that were being produced by cities need to be considered coherently, because they tend to pollute air, to make air toxic. And so he makes these amazing sections where all these different issues are put together, and one of them is air. So this is the moment in which air starts becoming a concern of the physical structure of the city and the physical structure of architecture. Another maybe interesting reference is explained by Rainer Banham in his book The Well-Tempered Environment, which are the first cases in which air management which now is everywhere around us, becomes for the first time embedded into buildings, which are hospitals. So the kind of health concerns at the beginning of the 20th century actually these examples are at the end of the 19th century. The Belfast Royal Victoria Hospital, the Octagon in Liverpool are some of the first buildings where the conducting the management of air becomes physically part of the design of the building, and so that then is taken over by other architects like Le Corbusier in 1933. Le Corbusier was one of the people who was more sensitive to these concerns of the health in the cities, and so and air as part of that. So he literally talks about I don't know exactly what is the common translation of the term, but he has two concepts that are, I think, very important and very related to the management of air. One is what he calls the exact respiration, and the other one is called the neutralizing mur neutralisant in French, and respiration exacte. So these are the two terms that he uses: the neutralizing wall and the exact respirations as concepts that have to do with how buildings handle air to climatize or purify or maintain a certain environment. It's as if this idea from Sloterdijk that the design of air, that you can actually design air, is embedded into buildings. And of course, out of the architectural theory in America, a few years later, in the 1940s, air conditioning becomes almost like a default technology. So suddenly all suburban houses have an air conditioning machine that controls the air inside of the house, and that is a new standard that happens in America. It doesn't happen in Europe, but this idea that the control, the management of air is part of architecture is very much part of the American post-war scene, and it has to do also with, for example, the way in which walls are constructed with barriers, with vapor barriers, with plastic elements that are wrapping these bubbles of air. I mean, you can think about American suburban houses almost like little bubbles of controlled air. So you cannot really control the whole atmosphere, but you can control your little bubble. And your little bubble is built with a plastic membrane that keeps the air constrained. So those are, I mean, just kind of for you to think about these issues, how the thinking about air develops through the 20th century, and in parallel with obviously the development of certain technologies. Some of the technologies are basically cars who are producing fumes and are basically poisoning the atmosphere. So there are activists, and there is increased concern about the toxicity of air in cities because of the exhaust fumes of vehicles that have become also a standard part of American suburban life, and kind of radiating to the west and to the east. I mean, here you had the same issue in the 50s and the 60s. In the Korean post-war, the 60s. This kind of development of highways everywhere and everybody trying to own a car, etc., etc. So this is how the people become aware, not just the theories, but the people become aware of the importance of air control. And there is a number of parallel things that have to do with the other side of air, and the technologies that are devised to control this air. One of them is what was also happened in 1952, the same year in which the Great Smog happens in London. In the US, there is the polio epidemics, and they, in order to deal with the polio epidemics, which leaves people without the capacity to breathe, because they attack the muscles of the lungs, they constructed these machines where they put people inside in order to allow them to breathe. Later on in the 70s, I'm now going further from the 50s. In the 70s, the bubble boy was a famous character of a boy who could not live in the outside air because didn't have immune systems, and so it had to be permanently kept in this bubble of purified air. And lived for many years, but the images became like famous in the American imaginary of this boy who could not live outside the bubble. So I mean, in a way, what I am trying to explain, the iron lung, the bubble boy, and very important in America, the space race imagery. So the astronauts are also breathing controlled air, obviously, because there is no air out there. And so this idea of the bubble is something that becomes progressively embedded into the imaginary of Americans, particularly Americans, but kind of radiating to all Western countries, and maybe some of the countries that were more connected to the West, like Japan and Korea and Taiwan and so on and so forth, were probably part of that imaginary that came out on TV. And so people became kind of interested in this possibility of, I call it in the book that I wrote about the envelope, I call it the airtight mentality, because people wanted to control. Suddenly all these images convince the public that you could live and you should live in bubbles of air, but also bubbles of class, for example. I mean there's a whole phenomenology, maybe we talk about it, but that produced literally architectural images like Buckminster Fuller's New York Dome, 1960, that has to do with this whole imaginary of the space race and the iron lung and the bubble. So now, how do you control air on the scale of a city? You make a blob. You make a huge blob, and actually Fuller actually made some fairly serious calculations about the advantages of having this dome built. Or Banham again and François Dallegret, the environment bubble, 1965, Hausrucker-Co, the Oasis process. So this idea of the bubble becomes very much part of the collective imaginary. And don't think that the public was external to it, because we all became convinced that that's the way we should live. It is one of the problems that we have today, that we have building stock that is designed to be permanently air conditioned. So we, in a way, climate doesn't work, doesn't matter, because we can make bubbles of climate. We can control the air with buildings, and the air that we are breathing inside of buildings is controlled by a machine that takes in and kind of exhausts it, and so on and so forth. I mean, that irradiated from the American imaginary of air conditioning to all Western affected countries. So it is interesting that and this image of bubbles is basically what we all accepted as a default, and one of the casuistic that is now forcing us to spend a lot of money in maintaining buildings, servicing these bubbles. I don't know whether you know that to heat a building through air versus heating a building through radiation consumes about 6 times more energy. So radiators, which is the kind of more traditional way of heating buildings, is much more economic than heating the air, because you lose a lot of energy heating the air, so that the air is very comfortable because it's immediate, it's very fast, etc., but it has a huge cost that we have ignored because energy was very cheap and nobody was concerned about carbon emissions in the 50s and in the 60s, when this model that we are still in, that we have inherited, was conceived. So it is quite interesting that there were people. I mean, this is a drawing from Le Corbusier, as you can see, 47, 52, for the unité d'habitation, where the opposite happens. What you see there is almost like a continuity between nature and the inside of the buildings. Is the opposite of the airtight mentality of the post-war America. Is the idea that the building, the inside and the outside of the building are continuous, and there is a kind of exchange there that needs to be preserved. It needs to be preserved in terms of taking care that the environment around the buildings is vegetated, that you have nice views, and that the air is moving around quickly and exchanging with the outside. And I think what is interesting about this section, which has very much to do with that section that I showed you before from Eugene Henard, about the city, is that idea of thinking that the city and the building are a continuum, rather than the American idea that the building is a bubble in some kind of hostile environment, toxic environment. And that idea of thinking that there is this continuity is one of what I think is an interesting development in the 60s, 70s, which goes already against the airtight mentality, the bubble mentality. These are drawings by Maxwell Fry and Jane Drew that became concerned about tropical architecture in 1956. So they start thinking that buildings are not bubbles. Buildings are the interior and the exterior are connected and should be determined by climate. So in some ways, this is the opposite approach to the airtight mentality, the one that we see, and is the rediscovery of climate. So buildings have to perform in specific climates. They are not bubbles separated from their environment. But obviously for that you need to have, so I think that this idea of the diversification of climate that is contained in Fry and drew tropical architecture experiments, I think is quite interesting as a kind of split in modern architecture thinking between the airtight mentality and the climate-specific mentality, which serve maybe as an interesting discussion today to how should we design buildings. Another parallel history. I'm giving you kind of different threads that then you can do whatever you want with them, which is how do people started thinking then into designing whole climates in cities. And so one of the first one, which is not so well known in among architects, but it is very well known amongst climatologists, is Luke Howard, who is a scientist in England, 1818. So he publishes a book at the beginning of the 19th century called The Climate of London, where he for the first time, with observational work, developed a quantitative study of these climatic differences that are compiled in the climate book. Ebenezer Howard, also one of the people who starts thinking about cities as whole climate systems. The Garden City is, in a way, the first time where this idea of thinking that is not about designing bubbles, is about designing whole environments, whole climates. So he designed for the first time the first garden city, Letchworth, which is actually built in the outskirts of London by Unwin and Parker in 1905, 1907. This is how it looks. And then this is another scientists who starts thinking about the plan of the city as relevant to creating a healthy environment for citizens. That's Augustine Ray, is not as well known, but is part of this kind of hygienist thinkers that start thinking about the city as a climate unit that affects the life of citizens, and publishes this book called The Plan de Ville, which is a series of plans of cities where he explains how they work, how do they relate to the green belt, to how the air moves through the green belt in order to clean the air inside of the city. And it is interesting that he is sensitive to these first attempts. I mean, when I was talking about that map that we can see now, these are the very first attempts that I know, and they date back from 1878. I can hardly see it here, but you can see that this is for the inside of the building. But these are first attempts to visualize how air moves inside of a room. So people are trying to imagine what is happening in this element that we cannot see, but we know it affects us. So, so one of the interesting things about Augustine Ray is that he starts using these same graphic devices to try to capture how air is going to move into cities. These are the first examples I know from somebody who tries to imagine that before being able to model or visualize it. So in some ways, these are the kind of ancestors of these CFD animations that we can, and modelings that we can do today using computers. And these are examples of competitions that he does in 1907 for a project, for the Rothschilds, etc., etc. It doesn't matter. I'm just now starting to show you how people are trying to grasp how air moves inside cities and what we can do with the massing of the buildings in order to control air. The idea of a wind tunnel, which is something that is designed to make airplanes and maybe in other cases ships, etc., etc. So these machines that enable us to test models are for the first time conceived by the Wright brothers, the first people who started flying with or who made a plane and managed to make it fly. This is the first example of a wind tunnel that was built in order to test these kind of things, and it is very interesting, and probably you haven't heard about this, but this is the real reason for the Tour Eiffel, is that Eiffel wanted to have a climate observatory. So this was not built in order to make something beautiful. It was built in order to make something very tall in the center of the city that allowed Eiffel, who was a scientist and an engineer and a scientist also, to measure air. And so Eiffel had this kind of apartment. He was himself living for a while inside of the Tour Eiffel, where he was managing certain measuring devices to understand how air moved in Paris. And he also constructed in the Champ de Mars, in the same place of the Tour Eiffel, this wind tunnel where he could test the effects of air resistance on scale models of buildings. So now I'm showing you how people try to grasp how air moves, because they couldn't see it. We cannot see it. We can only model it. And so one of the examples of of this trying to grasp the mechanisms of air was devised by Eiffel, and then by Eugene Marey in 1901. Also, all this modeling of air and flow, and to try to visualize how air moves, happened at the beginning of the 20th century, and it's something that obviously we now can do very easily using CFD models, but at the time it was not that immediate. And so Marey was one of the things that he was doing was to blow smoke at objects and try to see, to photograph how the smoke moved around objects, and how to basically make a hypothesis of if smoke moves. Smoke, we can see the smoke, we cannot see the air, but his hypothesis is that the air would move like the smoke. Sorry. And so that basically was then taken in the 30s. I mean, these are some of the earliest examples of effective urban planning, and this happened in the Weimar era in Germany, in Frankfurt, where Ernst May, who was an urbanist, was basically in charge of the urbanism in Frankfurt, and invented something that is incredible, looking look with hindsight, incredible, because he called it the green politic Frankfurt. So he was one of the first people who started thinking about greening cities as a way of purifying the atmosphere in cities, and made this kind of maps like the one you see there, where by locating parks strategically around the cities, around the city of Frankfurt, he managed to purify and filter the air. So Ernst May was basically one of the first people who understood that the city is a microclimate and can be constructed, can be controlled. And then went on to, he became basically a global urbanist, and he actually had a very, very important role in the planning of the Soviet urbanism in the once the Soviet Union became formed, they brought in Ernst May as a kind of guest urbanist to plan many of the cities, but not only that, he also had practices in Kampala, in many different places. Ernst May, Ludwig Hilbersheimer was somebody else who was also interested in this case, planning the grain of the city in order to produce sufficient air exchange, let's say, in order to make cities healthy. And so here we are starting the first experiments where people, from trying to imagine how air moves, started to think, how should we make urban fabrics that will enhance airflow? So one of the ways in which we can keep the air healthy, so that we can breathe it, so that we don't need to make bubbles, is to basically create a great rate, what scientists call exchange rate of air in urban fabrics. And so there is a scientist called Landsberg, who is one of the first people who, after Howard was dealing with this issue, and Landsberg created this thing that you can see is the first maps of what we call today urban island effect. Have you heard about the urban island effect? Yes. Okay, so this guy, Landsberg, was the first one who measured it and saw that the temperature inside in the city is higher than in the immediate perimeter. So he didn't know exactly why that was happening, but he started basically measuring these effects, and again trying to map them, almost using the same tools that meteorologists used in order to delimit different temperature areas. One of the things, you need to think about this. I happen to my partner is basically a climate scientist, and she has kind of worked quite a lot on this, but her thesis was directed by a climatologist. One of the interesting things that are happening now in the urban planning disciplines is that we are starting to use tools that were exclusive to climatologists. And so climatologists used as the minimum pixel of information an area of 1 by 1 kilometer. Now what is interesting now, and this is happening in the climate sciences, is that climate is going to a higher and higher resolution. So climatologists wouldn't deal with the detail in less than 1 by 1 kilometer, But now they realize, because of urban science, that they need to increase the resolution of their maps. But so anyway, Landsberg, Kratzer, this is Albert Kratzer, is another German climatologist that started studying cities and using this kind of climate maps in order to show how the microclimate in cities operates. And so what we see is that Kratzer is one of the, or is maybe the first guy who realizes that the same thing that you can do to a large climate area, like a weather map showing a whole country, you can do it to a city. And you can see microclimates within the city. And so he is basically one of the first people that is trying to reduce the resolution of environmental data. I don't know why. I mean, this has to do, again, I mean, it's kind of recap on what we already mentioned about Le Corbusier thinking about the whole microclimate of the city, and Maxwell Fry talking, and Jane Drew talking about tropical architecture as the kind of, again, immediate result of starting to think that cities are microclimate and we can design them. So going forward in this process, and this is what I was already kind of introducing just a minute ago, the interesting thing that we are seeing now is that these kind of meteorological variables are starting to reduce, to become increasingly high resolution. And there is a number of mechanisms that are happening that people were already starting to develop. I mean, this is a graph that is from 1987, but it shows that there are different boundary layers. This is also a climate-specific term, which you probably haven't heard. Has anybody heard about the boundary layer? No? Okay, so the boundary layer is something that meteorologists use to show different regimes of air. And as you can see, there are different boundary layers in the atmosphere, depending on, I mean, the atmosphere works in a different way depending on the height from the ground. And what these people are starting to understand is that whatever we do on the on the lower layer, on the surface layer, has an effect into the urban boundary layer. So there are almost like borders in which air movement happens in a different manner, and those air borders depend on what is called the roughness sublayer. So the profile of the city has an effect on how air moves on a lower level, and then it scales up to the boundary layer of the atmosphere. So we can actually model the movement of air in the lower level, in the area that we build as architects or urbanists, in these three different layers: the surface layer, the mixing layer, and the urban boundary layer. So the way we are starting to think about urban heat island. I mean, we mentioned already the concept of urban heat island. Landsberg is the first person who deals with that. So why is that the urban heat island takes place and produces a different air regime? Because if you can imagine, if the surface of the earth is flat, all the solar radiation falls onto the surface of the air, of the earth, and depending on the color and the material, then gets absorbed or gets reflected. Have you ever heard of albedo? No? You don't know what albedo is. We're going to talk about it when we talk about energy, but basically albedo is a coefficient of how much of the solar energy is absorbed or reflected in the surface of the building. So what happens when you corrugate the surface of the ground by putting buildings on it is that there is more surface that is collecting radiation from the sun. And that is one of the reasons why the temperature rises, because you have more surface that is absorbing solar radiation and is also reflecting inside. And so that's basically what produces this increase of temperature towards the center of the city that that increases the temperature, and actually is something that you can see in aerial photographs around cities, that they produce these kind of holes in the atmosphere because of the increase of temperature. So in some ways what this leads us is that, you know, this is the way we conceived cities. There were buildings and external spaces connected from buildings. Then in the modernist moment, we started to think that the interior of the building should be an independent, so this is the kind of bubble moment in which buildings have internal atmospheres that we can control by using energy and by using certain technologies. And I think what we are now is that we are back to this idea from Le Corbusier or Jean Vieux, where we have to design the inside and the outside together, and it's not just that we can plant trees in order to purify the air around buildings so that the air is more healthy, but the form of the buildings, the massing of the buildings has an impact on how air moves. So these are actually drawings from Maider, my partner, who, as I said, works on these issues. And what is interesting about these maps is that those are maps that are done using LES, which is a kind of complex CFD modeling software in order to see how air moves around buildings, but this is also, so it's a kind of hybrid map using wind tunnels and LES systems to model the way air moves around buildings. And one of the interesting things that she found in these studies was that the pitch roofs or round roofs produce a much higher exchange rate of air in urban canyons. These are kind of studies, they call it urban canyons, which are these spaces in between buildings. So if you have a pitch roof, the amount of the exchange rate of air is much higher than when you have flat roofs for a certain height. I can't remember, 4 or 5 story high buildings, urban canyons increase the air rate depending on the shape of the buildings and depending also on the amount of balconies. So the ruggedness of the surface of the building has a direct impact in air movement. So that's something that basically we can visualize and we can control in buildings, and depending on on the form that we give to buildings, we are going to create different air air systems. I think that maybe we're getting close to the end and of this session. Now I would like just simply to mention a number of policies. So we've seen also we've seen now the history of the thinking of air through the 19th and 20th century. We've seen how it gets integrated in buildings and in urban fabrics. We've seen the tools that have been progressively being constructed in order to enable us to map and to model the air. And now we're going to see what have been the policies, what have governments done in order to control or to improve microclimate in cities. As I said at the very beginning of the lecture, this is data from 2014, and I've read later on even more worrying statistics about people dying related to air pollution. This is from the World Health Organization. 7 million people in the world died of air pollution, and so obviously we talk about the gray smog in 1952 and the Health Act passed in 1956 as a result of the great smog. We haven't talked about Rachel Carson. Have you heard from Rachel Carson? No? Rachel Carson was a kind of activist in the 60s in America who was a very influential character who basically produced the first US Clean Air Act in 1963 as a result of a book that was became very famous in the 60s called Silent Spring, which is one of the historical texts of environmental activists worldwide. So after this is the still from actually Frank Lloyd Wright movie called which he did in order to promote Broadacre City, the kind of expansion of cities beyond New York and Chicago and the kind of urban centers into cities that are more embedded into the territory. And he was basically referring to the smog in New York in 1966, and immediately after the Air Quality Act 1967, which was an amendment on the Clean Air Act that Rachel Carson had produced in 1963. This is Richard Nixon signing the Clean Air Act in 1970. The next example, or the next iteration of clean acts in the U.S. George W. Bush in 1992 signing the first climate change agreement in the UN Conference of the Environment in Rio de Janeiro. So then, I mean, this is basically, this has to do with moving these policies to some sort of global policies. This is Pruitt, who was Scott Pruitt was the director of the Environmental Protection Agency in the US under Trump, who was basically rolling back these policies. What you can, and this is again Andrea Letson, which was interested in reducing burdens on EU red tape. So what you can see is that these things are political. I mean, depending on the politics, policies take place. So maybe Trump versus Macron, or and so these are. I mean, already seen this. It is quite interesting to see that most of these global policies are fairly toothless. They have very little effect on the way things end up working. And what I would like this is a kind of example of how different air quality standards apply in different environments. Unfortunately, I don't know the environments in Korea. Maybe somebody can find out, but this is how national or even continental regulations limit ozone emission, fine particulate, sulfur dioxide, nitrogen dioxide, and carbon monoxide, which are the main parameters that are used to measure the quality of the atmosphere by regulations. And you can see actually that the American one is the most permissive one in most I think in all cases. The American one is much more permissive than the European one or the Canadian one, etc., etc. So the question of who sets up the quality standards of air on a kind of global or on a national or even on a local, which is basically the thing that I would like to maybe propose for you to think after as a kind of outcome of this session, which is that one of the things that is happening now in many places is that there are policies that are increasingly localized, which I think, most of the policies that governments use to control the quality of air are of a very large scale. But because of the development of certain technologies today, we can start developing policies that have a much more specific and local effect. So that has to do with the tools that we have. This is the first weather station in Athens, which is called the Tower of the Aides, the Tower of Winds 50 before Christ. This is the way we are looking at concentration of particles in a city today, based on something that is called open sense. So what is interesting about now is that we have many different ways of sensing climate parameters. So all these parameters that are dictated by global policies, almost on a continental or on a national level, are to some degree useless in terms of designing cities. Particularly when we have increasingly sophisticated tools to measure the quality of air by different ways. Let's move quickly. I didn't remember I had this session also here, but maybe I'll mention some few things about this. This is the way we used to climatologists used to measure air quality. So we had these kind of weather stations that were actually quite sophisticated and quite expensive to run and very precise, but they produce a very low resolution of data. When we were talking before about the resolution of data, so climatologists using 1 by 1 kilometer, but urban climatologists using a much closer resolution. So these weather stations were designed for climatologists. So they are located, 30 kilometers apart. They're super precise. They're super expensive. But they have very little resolution. So we cannot really design urban microclimates using this technology. What is interesting now is that we have this technology, which is basically a technology based on what is called smart citizen platforms, which means that there are people who are having mini weather stations that are perhaps not so precise, even they're very imprecise, like mobile phones that are enabled to measure certain parameters, or DIY sensing. So there is an increasing amount of agents in urban environments that can measure the quality of air in cities. So as opposed to the weather stations that are very scientific, very precise, calibrated, expensive, require very high expertise to manage, and they have very high time resolution, which means that in the location where they are placed, they can measure with great precision the variations of these parameters in time, but they have a very low spatial resolution against or as opposed to weather stations. Today what we are increasingly seeing is that we have access to DIY sensing, which is basically crowdsourced data. And crowdsourced data are much less precise. They are achieved through redundancy. They are cheap. They have a medium time resolution, so they are not constantly measuring precisely the changes in the parameters, but they offer a much higher spatial resolution. So you can know more or less what is happening in closer environments, and therefore you can act. You can act to the point where you get a message in your cell phone saying this route today has a very high concentration of carbon monoxide, don't cycle through it. And so people are going through a different path. So this kind of infrastructure based on citizens' practices are increasingly available in large cities. I don't know exactly what is the situation in Seoul, but in London there are quite a few of these websites that produce these kind of messages and enable us to look at air pollution, for example, with a much higher resolution. So basically what we are seeing in these technologies is that we are going to a mesoscale, to a microscale of the models. That's the kind of advantage that this capacity to measure urban microclimates gives us now. In terms of being able to map all these parameters, the nitrogen concentration, the fine particulate content of air, etc., is something that is increasingly localized. So there are examples of these technologies where you know that the fine particles or the VOCs in the volatile organic components in certain areas of the city are higher than others. And they are starting to affect, in some cases in the United States, they're starting to affect real estate. This is something that happened traditionally in cities. I think in I can't remember now. In Seoul, the air is mainly, the rose wind of Seoul, air is coming mostly from the northwest, if I remember correctly. Right? Do you know this? It's northwest, right? So generally speaking, in other cities, the most expensive real estate would be located in the place where the wind is coming from, because that was the healthier areas in the city. So that was a kind of intuitive, popular wisdom that has been operated in cities forever, basically. So people downstream, both in terms of water movement and in terms of air movement, are bad. Upstream is good. But now we have mechanisms that enable us to, because maybe downstream, but it is behind some sort of park that purifies the air, or is behind the mountain, and therefore the boundary layer goes somewhere else. So we can start to plan the movement of air in cities with much more precision due to the availability of these technologies that enable you to see cities with this level of precision. I believe that if I could make a prediction about where this is going to local agency, to increasingly smaller scale policy units that are going to be deciding about microclimates in the sense of micro scale, small scale of operation, as opposed to these kind of large scale policies that we were seeing, Bush and Nixon and blah blah blah, saying okay, the parameters have to be these for good quality. I mean, not that this is irrelevant, it is obviously very relevant, but it's not a tool that we can use as urban planners or architects. The tools that we can use are becoming available now, were not available 10 years ago, and will take time to be fully usable. But I believe, and this is something that we will see almost through every one of the urban ecologies, that probably the next future is going to be about localization. We'll see it in the management of water, we'll see it in the management of energy, we'll see it in the management of production and recycling. So this is, I think, if I could maybe make some sort of forecast of things that we are going to see in the future sessions, I think that this is where urban thinking, urban ecologies is going to go. It's going to go to increasingly smaller scale of policy. I think this is the last slide. I don't really have anything else to tell you. Maybe about air, but I don't know if any of you want to mention something or has a question about any of these issues. I'm happy to answer or to try to engage with you in a conversation about it.